Physics 1. Okay, physics, I've already talked about this, but x is the position. AP tends to use x. X prime is v. V is velocity. V prime is the second derivative of x, which is also equal to acceleration. You can just do the derivative of each equation to get to the next one. We are going to go over optimization tomorrow, by the way. So if you're like, wait, is he just skipping it and not teaching it? No, I will. I totally will. Here, let me show you something real quick. So in physics, you guys have this equation where it's like, I might have shown this already, so if I have, I apologize. Sometimes that's labeled as the height. Doesn't really matter. What do you guys use height here, like the initial height? What do you use? This is a free fall equation. Now watch this. If you do the derivative, check this out. You get negative 9.8 t plus the initial velocity. That should match your equations that you already have. And then if you do the, wait, that's supposed to be the first derivative. If you do the second derivative, you get negative 9.8. Okay, which is the acceleration, due to gravity at, the basic heights that we deal with in physics. Obviously, that's less if you get further away from an object with mass. An object with mass, an object, yes, because every object has mass, right? Now, you don't need to know that. I'm just kind of showing you where all that stuff comes from. I mean, you can also do all that with algebra, but. All right, so let's look at an example problem here. Oh, we're going to talk about this later, but there is always a question of whether the speed increases or decreases. And the main thing is, if something is going to speed up, the velocity and the acceleration have to have the same sign. You probably know this from physics already, but if you are going in the negative direction and you're accelerating in the negative direction, then you're technically speeding up, even though you're really going down with velocity because of that. Does that make sense? Because the negative positive is a direction with velocity. With speed, though, it doesn't have a direction. If they have opposite signs, then it's automatically slowing down. Okay, so if you are accelerating, the velocity is in the positive, it's positive, and the acceleration is negative, you're slowing down technically. Okay, if the velocity is negative and your positive acceleration, you're still slowing down, even though the positive and negatives might confuse you. But the main thing is if they match. If they match, you're speeding up. If you're not, then you're slowing down. And there's always one question on that for every free response. Like you can look at every test. It always asks this. It's crazy. Here is what a physics problem looks like in, it says S of t, but just treat that as x of t. But this is what a physics problem looks like in calculus. I only have 3 minutes to do this, so. All right. Try to do this with physics, and then try to do it with calc. It's a little dynamic here. All right, so we are looking for what is the velocity of the particle when its acceleration, so when a is equal to 0. That's what that's asking for. So first thing you need to do is figure out when is the acceleration equal to 0. So let's find our velocity equation first. And that's just going to be 4 sine of t minus t, right? I just did the derivative of position here. The acceleration of this is going to be 4 cosine t minus 1. Okay, and we're looking for where this is, when this occurs at 0. When is this acceleration equal to 0? Was this a calculator problem? I didn't write it down. All right, so you're going to have cosine of t is equal to 1 over 4. Okay. Yeah, I should have said use your calculator on that. Sorry. That's embarrassing. Dang it. One time I didn't bring a calculator. But you have the internet. Yep. Arc cosine of 1/4. Okay, let's round. By the way, the physics ones, it doesn't. You're not going to have an answer with like a radical and stuff in there usually because it's the real world. You don't. No physicist just writes, "Oh, the square root of 3 is the answer." Okay, because you have to deal with measurements. Anytime you have measurements, then you have significant figures. If you have significant figures, you can't do root 3. So 1.318. All right, and there's a bunch of change on that too, which you are going to need. Probably don't need this many, but you don't want to truncate it because sometimes it throws off your answer. Okay? And then it says, what is the velocity at this t? So what we're going to do is we're going to find v of, let's just call this a, v of a. Okay. So that means we need to take the, was it sine? Yes. 4 sine of, just say a minus a. We're going to say that this is equal to a. Then you get 2.555 for your answer. Because t is a variable here, I wanted to make it a constant. I knew someone was going to ask that.
Would matter if you're doing this on an actual problem.
I know, I'm trying to think of what AP would do. I don't know. I'm sure they would give it to you because I don't think they're that much of a stickler, but you really shouldn't because this t is different than these t's here because that's all treated as a variable. I wouldn't mark it wrong, however you want to do it.